Today we're going to be covering section 2.6. Here I want to discuss what an even and an odd function is first. So let f be a function. F is even if f of negative x is equal to f of x for all x in the domain of f. And what this means is that the y value is the same whether we plug in something like -2 or +2. So the y value would be the same result if we plugged in the negative of a value or the positive of that same value. F is defined to be odd if f of negative x is negative f of x for all x in the domain of f. And here, that just means that if x is the negative version of some value, then the y value is just negative of what you would have gotten if you had plugged in the positive value of x. So, let's try to determine whether a function is even, odd, or neither. So I want to start with the example f of x is equal to x to the 6th plus x. To determine whether this function is even, odd, or neither, we need to find f of negative x. So that means plug in negative x everywhere we see an x. So this would be negative x to the 6th plus negative x. Well, if we take negative x and we raise that to the 6th, that's an even number of times we're multiplying it, so that value ends up being positive. So this ends up being positive x to the 6th. This is plus a negative x, or in other words, just minus x. And notice that this is neither f of x, nor is it negative f of x. So this is neither. We can continue on with a second example here. And this is going to be x to the 4th plus x squared plus 3. Again, what do? We plug in negative x. So this would be negative x to the 4th plus negative x squared plus 3. Negative x to the 4th is the same as positive x to the 4th, because again we're multiplying an even number of times. Same thing for negative x squared. This is the same as positive x squared. And then of course we just still have plus 3. Well, this is our original function, f of x. So this tells us that f of x equal to x to the 4th plus x squared plus 3 is an even function. All right. So I want to continue on. We have one other thing I want to look at in section 2.6. And that would be graphing transformations. So to do a graph by transformations, we start with the graph of a standard function and then use transformations to sketch. So this is like horizontal or vertical shifting, horizontal or vertical stretching, reflections, etc. And so to do this, what we want to do is we want to start with a sketch of our base function. So here, if we're going to sketch negative square root of x plus 3 minus 2, the base function here is y is equal to square root of x. So we want to start with that. Well, we know how to graph that, right? Y equals square root of x looks like 0, 0, 1, 1, and 4, 2. So it looks like this. And so this is the square root of x function. Now to sketch using transformations, I want to start with the first thing that happens to x. So x, inside the square root we have x plus 3, so the first thing that happens to x is we add 3. If we add 3 on the inside of our function, then that means it is a horizontal shift, but to the left, right? If we add 3, that means move it left 3. If we had subtracted 3, that would have moved it right 3. So this plus 3 moves our function to the left 3 units. So we move everything to the left 3 units. And this is the function, the square root of x plus 3. Then what's the next thing that happens? So the next thing is we multiply this by a -1. That is a reflection through the x-axis. Right? We flip it down. So we take this previous graph that we just wrote down, the square root of x plus 3, and we want to reflect that through the x-axis. So this right here is the negative square root of x plus 3. Then, what's the last thing that happens up here? Well, then we subtract 2. Subtraction of 2 on the outside of this function means a vertical shift. In particular, -2 means we move the graph 2 units down. So I want to move everything in this negative square root of x plus 3 down 2 units. And we have done so now. And so this function that we have sketched here is the negative square root of x plus 3, all minus 2.